Welcome back to another video. Today in probability, we're going to look at something called compound events. Now this video is going to feature a few probability concepts for grade 6 and grade 7. So let's get started. As you can see here, I've drawn two spinners right now. This one here is separated by orange and blue, and this one separated by 1, 2, and 3. When we look at this spinner here, we need to look at what is the probability of landing on orange or blue. Well, to land on orange, it's 1 over 2 because there are only two parts to this spinner and one part is orange and it's equal to the other part. So that means blue is 1 over 2. On this spinner here, what is the probability of landing on 1? Well, as we can see, it's separated into 3 parts and there's only 1, 1. And same with 2, there's only 1, 2. And there's only 1, 3. So to land on a 1, 2, or 3, you have a 1 in 3 chance. To land on a color, it's 1 in 2. Now I want to conduct an experiment, and my experiment will be, in order to have no homework tonight, let's use this as an example, you need to spin an orange and land on 2. Okay, so how can we figure out what is the probability of this happening? So the first thing we need to do is look at the spinner. There's orange and there's blue. If you land on orange, there are 3 options that would follow for this spinner because there are only 3 options here. And your options would be 1, 2, 3. Same with blue. If you were to land on blue, you would lose the game, but you would still have 1, 2, and 3. So by looking at this tree diagram, this is the tree diagram. It was featured in another video on my page. It tells us that there are 6 possible outcomes. So in order for this to happen here, it's 1 over 6. Or 0.16 or 16%. And I did that by doing 1 divided by 6. That's in the fractions unit. So I'm going to show you an easier way to do this. So you don't have to draw a tree diagram all the time, because sometimes there's dice outcomes as well and spinners with more parts to it. So this is easy to draw a tree diagram because there's 2 small spinners in play. But when it gets harder, I'm going to show you why this trick is better. So you look at this here. So let's call this the trick. This is the best part of the lesson, I promise you. Okay. I want to get orange. I know orange is 1 over 2. So you write 1 over 2. And here I'm just going to put an O for orange so we can differentiate what we're talking about here, so we know what's going on. And I'd like to land on 2. I need to land on 2. So I'm going to put 2 in brackets here. 2 is 1 in 3. Now, to get the probability, all I need to do is take 1 over 2, multiply it by 1 over 3, and that'll equal 1 over 6. That's how you would do a compound event when it comes to probability. Okay, I'm going to show you another example, but this time with dice. Okay, so let's grab 2 paired dice. Monopoly is a game that we all love to play. Most of us are playing it incorrectly, but whatever, as long as it passes the time. So there are 2 dice here. Okay, let's keep them here at the top. So let's look at how many outcomes are there on this die. So you can get a 1, a 2, a 3, a 4, a 5, and a 6. Same with this one here, 1, 2, 3, 4, 5, 6. So the probability of landing on any number is 1 over 6. Okay, because there are 6 sides to the dice. So now, we know that in Monopoly, if you get doubles, it's good because you spin again. But if you get them 3 times in a row, this is bad news. Well, let's find out what is the probability of getting doubles. So let's pick any number. Let's do 6s. To get a double six, okay, so I want to get double six. So it's going to look like this. Okay, double six will look like this. Well, in the first die, it's 1 over 6. In the second die, it's 1 over 6. The probability of you getting double sixes is 1 over 36. What that means is if you take your dice and you roll them 36 times, in theory, you will land on double six one time. I'm going to just do it once. Well, I got this. So anyways, that is the probability of getting a double six. What is the probability of getting double six 2 times in a row? It's happened. Well, if to get it 1 time is 1 in 36, to get it 2 times is also 1 over 36. And for this example, I'm going to need a calculator. So I'm going to take, well, we know 1 times 1 is 1. 36 multiplied by 36. Well, there is your probability of getting back-to-back double sixes. 3 times in a row, you ask? Well, you would just multiply it 3 times. We know 1 times 1 times 1 is 1. I've already multiplied 36 2 times. Let's do it a 3rd time. Well then, these are your chances of getting 3 straight double sixes. Okay, so this is just to give you an idea of when you're playing Monopoly and you're in jail and you can roll yourself out with a double. You have a 1 in 36 chance of getting a double. But this should also help you play this game with more success, hopefully. The last example I would like to look at is a deck of cards. Now, I don't have a deck of cards handy with me, but I'm going to go over what is in a deck of cards. Okay. Deck of cards has numbers 2, 3, 4, 5, 6, 7, 8, 9, 10. And the suits are Jack, Queen, King, and Ace. So these are all the cards that are in a deck of cards. There are 13 different cards. Plus, each card has 4 different symbols. So, diamond, it goes club, it goes heart, it goes spade. And each of them has that. Thank you to the power of editing. You did not have to sit through all this. But this is what's in a deck of cards. I'm not including the jokers because nobody really uses them. 52 cards. Okay. If I had a deck of cards and I said to you, okay, you need to draw a 7 of clubs in order to win the game. Well, there's only 1 7 of clubs. You have 1 in 52 chance of winning this game. So just say I do shuffle the deck, whatever, and I pull out Ace of Diamonds. Ace of Diamonds. Okay? And I remove that card from the deck, it's out. You now have a 1 in 51 chance of winning this game. So as you remove things, so just say you remove a card out of the deck, your probability increases. Okay? But if I put that card back in the deck, then it's fair game again. It's 1 over 52. Okay? So that's another example of probability being used with cards. Now, as you can see here, you do not want to do a tree diagram for this. This is too much. Okay? But I will do some multiplication for you. So let's make an easier game. Let's say you will win this game if you roll a 5. So you need to roll a 5 and draw an ace from the deck of cards. So draw means you just take it out of the deck of cards. Well, let's find out what your probability is of this happening. Well, to roll a 5, let's do the math up here. Let's use up the space here on this page. To roll a 5, so a 5, so dice. To get a 5 is 1 over 6. Now to get an ace, any ace here, well, there's 4 out of 52, but it's also 4 over 52 reduces to 1 over 13. So I'm going to go with the reduced fractions. I hope you see why reducing fractions is necessary here and why you should have been doing it the whole time. And that's why I was pushing it too. So to get an ace is 1 over 13. Now to get the probability of you winning this game, you must take 1 over 6. You need to multiply it by 1 over 13. And the answer you will find is 1 in 78. You have a 1 in 78 chance of winning this game. So this game is not in your favor. It is definitely in my favor. And the probability of this event happening is highly unlikely, as mentioned in a previous video. And if you didn't watch the previous video, it might be in the grade 6 side of things. So please check the videos of probability on my channel, or just watch another video from another content creator. I'm sure their videos are much better than mine. Okay, I don't know what else I can mention about probability. Probability is everywhere. And if you remember, it's always out of 1. So 0 to 1, you cannot have a probability greater than 1. So that means you cannot have probability that looks like this, 7 over 4. That can't happen, it's impossible. But you can have, so this is wrong, you can have 4 over 7. This is good. The numerator must be smaller or equal to the denominator. It cannot be bigger. Okay? You can't say you have a 2.5 chance of winning this game. That is impossible. This cannot happen. Okay, so please keep that in mind. There needs to be a 0 in front or a 1. If it's 1, it's certain, but it can only be 1. It can't be 1.1 or 1.01. It's 1, just 1, 1, lonely 1. But you may see something like this. Yeah, in baseball statistics, the batter bats .405. What this means in baseball is it is basically a percentage out of 1,000. So for every 1,000 at bats, the hitter's going to hit the ball 405 times. Now I know what you're thinking, that's not good. In baseball, this is actually excellent. So even though it's almost unlikely for the batter to get a hit, this is still a really good average. Most baseball players' averages are decimal 260 for like a decent player. So that means 260 times they'll get a hit out of 1,000 times. That's about 1 in 4. So it's kind of crazy. But there is no baseball happening right now because of COVID, so we can't really use examples right now. But when baseball season starts and you remember this video, I don't know, you can ask me again or make another video. Anyways, that's it for the probability unit for grade 7. So I hope you enjoyed the series of probability videos on my channel. And yeah, I'll see you in the next video. Thanks for watching. Bye-bye.